Hi everyone, this is Matt Show with Intro Stats, and today we're looking at a problem from my book, Intro to Statistics for Community College Students. This is section 4B as in boy, number 32, and this is the section on ANOVA. So we're doing an ANOVA simulation with StatKey today. It says let's kind of look at the problem here. It says, this is number 32 in section 4B, under the ANOVA for difference in means menu in StatKey, click on the pulse rate and award data. This data looks at the average pulse rates of those people that have won Olympic Academy and Nobel Awards. Use a 1% significance level to test the claim the population mean average pulse rate is related to the type of award that is won. Now we have to sort of digest this a little bit. We already know that ANOVA is a categorical quantitative test, right? We're trying to see if a categorical data set is related to a quantitative data set. Looks to me like the type of award that is won is going to be the categorical data set. And then the pulse rate of the person, the average pulse rate of the person, will be the quantitative data set. Remember, if the mean average pulse rates were equal for the three awards, then that would indicate not related, right? It wouldn't matter what award they got, they have about the same pulse rate. So that means in a sense that the award they won is not related to their pulse. But if the mean average pulse rate was related, then we would see that the mean average pulses would be different for these awards, right? So if at least one is different, then that might indicate that somehow winning these awards is somehow related to pulse rates. And that's what we're actually testing. They want us to test the claim that they are related. So I would expect, if that's the case, I would expect the mean average pulse rates to actually be significantly different in these award groups. All right, so let's take a look at the problem. Again, we're going to go to lock5stat.com, click on StatKey, and ANOVA for difference in means is in the bottom right corner. So we're going to click on that. There we go. We're looking for award data here. Let's see if it's here. Student award, there it is. Student survey, pulse and award. So pulse and award, there we go. So, it looks like we're looking at pulse and award. All right, so if we go ahead and take a look at this here, let's look at this data a little bit. Here's our original sample. This is our F test statistic right here under original sample. It's already calculated. F equals 7.104. The variance between the groups is about 7 times bigger than the variance within. If I want to see the actual numbers, I can click Anova Table here. Here's the variance between the groups, 1,023, and the variance within was 144. And again, the variance between is about 7 times bigger than the variance within. I can see the degrees of freedom and the sum of squares, and that's just kind of how the F was calculated. Let's take a look real quick at the standard deviation since they listed them here. We don't want any of them to be more than twice as big as any other. They're all like 11, 12, or 13, so it doesn't look like any of them are more than twice as big as any other. So that's a good sign. And let's go ahead and simulate and figure this out. Now again, our null hypothesis is that the three award groups have the same mean average pulse rate. Again, that would indicate not related. If at least one is not equal, that would be the alternative hypothesis, then that could indicate they are related. So let's go ahead and generate a few thousand samples. We're simulating the null hypothesis. Okay, remember ANOVA is always a right-tailed test. The problem said to use a 1% significance level. So we're using a 1%. That means the percentage in the tail should be 1%. So let's try that. I'm going to change the tail to 0.01. Okay, so at a 1% significance level, now what the computer did again is they calculated thousands of F test statistics. So they took thousands of random samples, created thousands of F test statistics, put them on the same distribution. So these are F test statistics. So this really is a critical value right here. This is an estimate of the critical value. So the computer thinks, or the simulation thinks, that the F test statistic has to be 4.717 or greater to be considered significant. Well, let's look at our original sample F. Our original sample F was 7.104, which definitely is falling in the tail, right? Here's our tail, here's 7. So it definitely is falling in the tail determined by the critical value. So that means our sample data does significantly disagree with the null hypothesis, and also means our variance between is significantly higher than the variance within. All right, now what about the p-value? Remember, this is just showing me the tail right now. This is not a p-value. The p-value is the probability of the original sample data. So we got to figure out this original sample F. So this original sample F, 7.104, type that in this bottom box right here. 7.104. There we go. And there we go. So there's our p-value. So the probability of getting the sample data, the 7.104, is the sample statistic, the statistic from the original sample data, or more extreme, right? We went considered any simulations higher than that by sampling variability. Remember, this is all by sampling variability if the null was true. It's right there. So this is a good picture of p-value. And there's our p-value, 0.0018. Very close to 0, 0.18% p-value. So that's definitely lower than our 1% significance level, so it's very unlikely to be sampling variability if the null was true, and we can reject the null hypothesis. But the claim, what was the claim? Let's review here. It said the claim was that they're related. Now, related in an Anova test, or really any relationship test, is always the alternative hypothesis. So rejecting the null, saying that we think the null is wrong, right? We're supporting HA, right? We're supporting the alternative. So we're going to really support this claim that they're related. All right. So there is our conclusion should be there is significant evidence to support the claim that the type of award is related to the pulse rate. And that, okay, so that would do it. So this is Mat 2 show and intro stats, and this was section 4B, number 32.